Okay, my name is Leo Cradaville, and I'm with Leopold ITT, and I'm a field service rep. Been with them about 13 years. So I'm here just to kind of explain, just go over this real quick. It really is, there's not a whole lot here. So what I'm going to do first is we're going to go over kind of how we install this real quick. When the contractors come out here, what they're going to do, the first step they do, so they're going to get on in the hole, shoot the grades. They find the highest point of the floor, okay? Once they find that highest point, they work, we have a grade line here of 12 7/8 to the top of the block. They'll shoot that around the wall, and that gives them a tabletop. So now they work everything from there down, so we know everything will be level. Their next step is they'll come in and they'll lay the anchor rods out. This is a front wall flume. Along the front wall flume, you have a series of anchor rods going in between the blocks. And what that is basically is that's the hold down system. So they'll come in, they'll drill them 5 inches in, clean them, blow them out, epoxy the rods in. After the rods are epoxied in, the next day we come back and we do a pull test on them. And we test them at 32 foot-pounds. If they stay in, we're good. If they don't, we pull them out, redo them until they pass. The next step is they have what they call a flat bar. Flat bar is a piece of, it's either stainless or just steel. And it goes from the anchor rod into the wall. We measure down 3 inches below the grade, drill that in, and then that sits in there level. And the height of that has to be about 11 inches to the top. It's real important because when you grout these, that is part of the hold down system, and I'll explain that. So their next step is to get the block down here and get it assembled. I don't know if you guys seen any of that done. It's kind of neat. The main blocks are 48 inches long. They have a bell and a spigot in. The makeup blocks are cut. In other words, if the fillers only measure 13 feet, they need makeups because they're 4-foot block. So they'll equal that out on both ends and make a makeup. The makeup block, what they do is after they cut them at the shop, and then we have an end plate out here that we put on. They seal it, staple it, put it in place. Then they get on there and they take an O-ring on the spigot end, and they put this O-ring on, and they take this tool and they snap these blocks together, and that makes one continuous lap, each one. After that's all done, then what they got to do is they start mixing up their cement for the grout bed. The cement is a 2-to-1 weight mix. It's a Portland and a masonry sand. That's all it is. And they use a type 2 Portland, so it's NFF approved and all that kind of stuff. So after they get that all mixed, we get on, they spread the mud out on the floor, about an inch, inch and a half. They lay that lateral in place, level it out, go to the next one. Just keep doing that until they're done. Once they get them all in, the next day we come back and you have a gap between them about an inch and a half, inch and 3/4. They grout in between that. It's the same mix, just a little more water so it's flowing. Once they get that in there, they slick the joints off, filter's completely done. So then we got to wait about 3 days, 72 hours. After about 72 hours, we come back to do our testing. And what the testing involves is, what we're going to do is we're going to bring water into that filter about 6 inches above the under drain. Once we get that in there, we're going to run the blower. Now here you have a PD blower. A PD blower means that it's a positive displacement. What that means is you cannot run that blower against the closed valve. Okay, you probably all know that because you've been using it. So what you have is a vent atmosphere valve. So what you're going to do, we're going to simulate until we have our controls up when we're testing. What they're going to do is they're going to open that isolation valve to the filter, open the vent atmosphere, start the blower up, close the vent atmosphere. And that should be a time valve, somewhere between close to 60 seconds from open to close. So once that once that air is starting to be introduced in, you'll see it come on, and what we look for on the test is a good even pattern over the filter. If we have any dead spots, we have to go in there and figure out why. You know, if we have a dead lateral, they might have got a little bit of concrete or something down in one of the pipes. Then we got to go in and make that repair. Once that's okay, then we do what we call concurrent wash. We're going to bring water in with the air. So what we do is we got the blower running. We introduce the water to the filter at about 5 GPMs. Let it get up to almost the bottom of the troughs. Shut the air off. Keep that at a low rate until we see all the air purged out. Then we slowly start ramping it up. Once we get it up to your high rate, which is about 20 GPMs per square foot, we'll let it run for maybe 3 to 5 minutes. Drain it down, get on and check the filter over. If everything looks good, the filter's good to go. The next step is the media. I don't know if you guys see them do that. What they have here is, because they have air, they have what they call an hourglass system with the rock. And what they do is they start out with a 3/4 by half. I think it's 3 inches deep here. And then the next one is a 3/4 by half, half by quarter, and so on until you get up to this fine, real fine stuff. It's almost like a pea gravel. Then they go back up to skin. So the last layer is going to be the same as the bottom layer, 3/4 by half. And that's what they call an hourglass system. And what that does is when they bring air and water in there, it won't let the media pass through that gravel. So it keeps it to support gravel. So once they get that all in, then they got garnet sand that goes in these. The garnet sand has to be leveled also, just like the rock. Each layer is put in, leveled, another layer in, leveled, so on. Once they get that all in there, then we backwash the rock. Make sure we get all the fines out of it and stuff like that. And then the next, like I said, the next layer is your garnet gravel. Put that in, level that out. And then after that, we put in our silica sand. Okay, the silica sand, you can pretty much pile it up in there. It don't have to be level. Just pile it up in there, and we estimate how much goes in there for how many inches. Once that's put in there, they backwash that, drain it, take the skims off, or take the fines off of it. What they do is they take a flat shovel, and they go in there and they skim it, maybe about 1/2 inch to 3/4. And the fines would be like real silty, like a clay. So you take them fines off, you wash it again, drain it and look at it. If it needs skimmed the second time, you do. If not, we're good to go with the next step. The next step is the anthracite, which is your coal. You put that in the same way. It don't have to be level because it's lighter than the sand. So you pile it up, backwash it, the fines come to the top, you get in and skim that, and then drain it down, check it, skim it again if we have to the second time, backwash it several times till it's clean. Then the filter's ready to be disinfected and put into service. So that's our testing. Okay, now for you guys, there's certain things you just want to watch as operators. If you're out here and you're doing, say you're doing a manual wash or something, when you drain that filter down to about 6 inches above the median, what you want to look for, make sure that surface is flat. If you have any mounding or any holes or depressions or anything, it's a good idea to wash it again and see if it comes back. If it comes back, then there's something wrong with the filter. It's either in your wash, something in your wash you're not doing right, or it could be something wrong with the underdrain. You might have flip-flopped the gravel, and the media is going to pass down inside. If you see that, put the filter out of service. You know, notify your supervisor, and then make a decision. You know, call us. They can talk to our engineers. They might be able to talk you through it. You know, well, this is what we think it is, blah, you know, or so on. Or we're going to send a guy down here to check it out. But don't keep running that filter if you see a hole. Because what that means is your media is passing into that underdrain. And if that underdrain packs up, it's no good. It has to be tore up. So it's real important for you guys to kind of keep an eye on that. Now your backwash procedure here is going to be what they call concurrent. That's what we had talked about. A concurrent is where you use air and water together. So what the computer's going to tell it to do, it's going to tell it to drain down to a set point, which is usually about 6 inches above the median. The air scour is going to come on like we talked about. The valves all sync together. Once that comes on, it's going to do that. It's going to air scour for maybe 1 to 3 minutes. And then once that happens, then the water's going to start coming in at a low rate, about 5 GPMs. And what that does is when you have the air sky running, it suspends all them particles up. Now you bring the water in and washes them out. So the filter will clean up quicker, you use less water on your backwash, and less time, okay? Once that gets up to the bottom of the troughs, the computer's going to say, okay, shut the air down. So the air will close, the valves will go back, and then it will slowly start ramping up that filter until it gets to that high rate. Once it gets to that high rate, it'll wash anywhere from, well, it all depends on the plant, but most of the time it's between 8 and 12 minutes it'll wash. Once that filter is clean, what's going to happen is it's going to, the backwash pump will slowly go back. In other words, when it's up at high rate, for any reason, you guys don't want, if you're doing a manual wash, it's at high rate, you don't want to shut that backwash pump off at high rate, because what happens is your media will not have time to re-stratify. So by lowering that rate a little bit at a time, the heavies fall first, and then, then the cold falls on top. So that keeps it stratified. And in a good filter, if you was to core sample, you dig down and you're going to see in the top 6 inches of that sand, you're going to see what they call salt and pepper. You're going to have a little bit of anthracite in the sand in there, and they call that, and that's a perfectly working good filter. You get that. So once they do that, then it's going to go into a rewash cycle, where until your turbidity drops. Once that drops, then it's going to go back and service. The effluent's going to open and back to the glue. So I mean, it's a real simple process. As far as moving parts, there isn't. There's no parts in here. So I mean, it's a pretty simple thing. But like I said, the main thing is for you guys just to be aware. If you do see any of this, go tell somebody. Let them come and see and say, oh yeah, we got a problem here, or wash it again and see if it levels out. Sometimes it'll mind a little bit because maybe your rate wasn't right or something if you're doing a manual wash. But it's a good idea every once in a while to watch, look at your filters and make sure they're operating right. If you ever take the filter down, like for some reason maintenance or something, when you drain that filter down, you want to start it as a new filter. Go back to this book, do a startup on it. So in other words, you want to bring the air in, or the water in real slow, purge all the air. There should be, we recommend, I think there is, we've got to talk about this yesterday, there should be some air relief valves throughout the system, probably on the highest point of the backwash pump. And what that does is that vents your air. Helps vent your air so you don't send slugs of air through the filter. If you see a lot of air in that filter, that's another thing to bring to somebody's attention. If you see big boils coming, that could mean the gravel bottom is rolled or something's wrong with the underground. So there's, just a few things you guys got to watch. But other than that, I mean, it's like I said, it's a pretty basic thing. So I think that's about it. I mean, we're going to do this short and sweet today. So I mean, you guys have any questions or anything?
Pretty similar to our other setup.
Yeah.
Over here.
Well, that's Leopold's block under that too. So I mean, but like I said, the key point is certain things for you guys to look for, and if you do take a filter down, make sure you bring it back like it's a new filter. Start it up. Anytime it's drained below that under drain, you have a good chance of having air in there. So you want to release that air, because that's what's going to damage the block.
What is the likelihood of that happening?
Slim to none. With the new plants, like I said, with the air release and all that, it's very, very rare now. The older plants sometimes will get that. And with this computer system, it'll show a lot of things in it. You go into the trends and you can see things. You can see I got a spike here or something happened, and we go back to that. If something does happen, we kind of look at that, investigate. What happened, so it don't happen again, But, I put thousands of these things in, over the years, and, like I said, had a handful of problems, and most of the time it's operators there, is what it is. That's about it. So, you don't have any questions, go back to work.